Okay, so this video is on graphing rational functions, and this is all about the asymptote rules. This is stuff that you should have learned in Math 3. If you're sitting in calculus now, you reviewed it in pre-cal. If you're headed into pre-cal, it's definitely something that you want to make sure you kind of have a pretty solid foundation. Once you get a hang of the rules, it's a piece of cake. You're going to use your calculator to graph it a lot, but you need to be able to find the asymptotes by hand. That's really important. So I'm going to say that one more time. You need to be able to find the asymptotes by hand. I don't want you to ballpark it on your calculator. Okay, so here are the rules. Asymptote rules. So we're going to let P of x be the top function and Q of x be the bottom function. So if I look at number 1, P of x is going to be the 2x squared, and the Q of x is going to be the x squared minus 4. Okay, so just it sort of looks at them as two separate functions. To find the vertical asymptotes. The vertical asymptotes occur at each real 0 of Q of x, which is the bottom. Now, zeros are the same thing as solutions. So to find vertical asymptotes, you're going to set the bottom equal to 0 and solve it. And those x equals solutions, now you got to remember from Math 1, like if I give you x equals 2, then that is a vertical line at 2. Well, now that this is an asymptote, you're going to draw it as a dotted line, because the definition of an asymptote is a boundary for the graph. It's where the graph can't go. It will be drawn closer to it, but it will never, ever touch it. It doesn't veer away from it. Like I said, it's almost like a magnet. It keeps getting closer and closer and closer, but it will never get there. So that's to find a vertical asymptote. So let's look at number 1. Let's just focus on vertical asymptotes. See if we can wrap our brains around that. So vertical asymptote, I set the bottom equal to 0 and I solve it. So I'm going to take the bottom and set it equal to 0, and that's quadratic. So I'm going to factor it. And then I'm going to set both of those equal to 0, which you guys can do lots of these steps in your head, but I'm just writing it out for those of you who may need a refresher course. So this x equals -2 and x equals +2 are my vertical asymptotes. So I'm not going to draw them as straight lines. I'm going to draw them as dotted lines because they are not my graph. They are where my graph can't go. They are kind of like fences. Okay. If I look at number 2 and I do the vertical asymptotes, I'm going to take the bottom and set it equal to 0 and solve it. So he's going to have a vertical asymptote at 2. And then for this one, I'm going to take the bottom and set it equal to 0. And it's a trinomial. Plus minus, so that would be x equals -4 and x equals +3. Okay, so we're just going to stay right here. So that's how you find vertical asymptotes. You find where the world will stop turning. Take the bottom, set it equal to 0, and solve it. Okay, now, horizontal asymptotes. A little different. Horizontal asymptotes have 3 different rules. 1, 2, 3. And it is all about the degree. If the degree, if the degree, if the degree. Okay, so first let's make sure we know what a degree is. The degree is the highest power. So if I look at number 1, the degree of the top is a 2 and the degree of the bottom is a 2. If I look at number 2, the degree of the top is a 1, the degree of the bottom is a 1. If I look at number 3, the degree of the top is a 1, the degree of the bottom is a 2. So again, it's not going to have anything to do with coefficients. It's the highest power. And so what these three rules do is they compare the degrees on the top to the degree on the bottom. So remember, P of X is the top. Oh, sorry. P of X is the top and Q of X is the bottom. So it says if the degree of the top is less than the degree of the bottom, so in other words, the bottom is bigger, then y equals 0. And y equals 0 is going to be a horizontal line at 0. So remember, x equals is a vertical line, y equals is a horizontal line. So if the bottom is bigger, then it's y equals 0 every time, all day long. Okay? If the degree of the top is equal to the degree of the bottom, then it's y equals a over b, okay? A is the leading coefficient of the top, and b is the leading coefficient of the bottom. Okay, so let me do a for instance. So if I have y equals 3x to the 5th minus 2x plus 1 over 6x to the 5th plus 7. Okay, so you can tell that the degree of the top is the same as the degree of the bottom. So no, I'm rule 2. And so I am y equals a over b, where a is the leading coefficient of the top and b is the leading coefficient of the bottom. So this is going to be y equals 3 over 6, which of course you're going to reduce to y equals 1/2. Now to graph that, you would go on a graph on the y-axis to a half and draw a horizontal line, because again, these are your horizontal asymptotes. So that's rule 2, and that's if the degrees are the same. If the degree of the top is greater than the degree of the bottom, then there are no horizontal asymptotes. Okay, so what what this says is that if the degree of the top is bigger, no, if the degree of the bottom, okay, hold on, stop, let's try this again. If they're the same, then it's y equals a over b. If the bottom degree is bigger, then it's y equals 0, and if the top degree is bigger, then there are none. And I was trying to get to a clean, I'm gonna go right here. Okay, so if top is bigger, there are none. Bottom is bigger, then it's y equals 0. And you can't just say 0 because 0 is not a line. These are horizontal asymptotes, so you have to write y equals 0, because if you write x equals 0, that's a vertical asymptote. So you have to have the y equals. If the top equals the bottom, then it's y equals a over b, where those guys are the leading coefficient of the top and the bottom. So that's the dumbed down version of these three horizontal asymptotes, and you just have to memorize them. Most of the time people have no problem with this because it makes sense that if they're equal, then you just take the leading coefficient of the top over the leading coefficient of the bottom. If the bottom is bigger, then it's y equals 0, and if the top is bigger, there are none. Just memorize it because you have to have it. Okay, so now when I look at number 1, I'm looking at my degrees, and the degree of the top is a 2 and the degree of the bottom is a 2, which means they are the same. So I'm this one. So I'm y equals a over b. So for my horizontal asymptote, I'm y equals the leading coefficient of the top over the leading coefficient of the bottom, which is 2 over 1, which is a 2. So I now come in here and draw a horizontal asymptote at 2. For number 2, the degree of the top is a 1, degree of the bottom is a 1, so they are the same. So my horizontal asymptote is y equals the leading coefficient of the top over the bottom, so that's a 1. And then on number 3, the degree of the bottom is bigger. So my horizontal asymptote is y equals 0. And then what I'm going to do is I'm going to graph this on my calculator because I haven't touched a graph yet. Like I don't know what these look like. I just know these are sort of like the skeleton, the bones that hold the graph up. And so I want you to take a second and grab your graphing calculator and graph these. And the one thing I want to point out is when you graph these, if, let me find a different color. If it has more than one term, when you graph it on your calculator, when you type it in, you have to put parentheses, but only if it has more than one term. So the tops of number 1 and number 3, you do not. And then when you graph them, let's see, let's do a green graph. You'll see, and this one's kind of close on the edge. He looks like that. And then does that, and then does that. This guy does that. And you can see how they fit into their asymptotes. So again, please don't say, oh, sure, I know how to graph these. If you don't have a lot of experience with graphing these on your calculator, please press pause and type them into your y equals and hit graph and make sure that you could draw him based on your calculator and the asymptotes. Okay, so now we're going to look at the last 3 down here, and we're not going to do the second page, so I'm just looking at these last 3. So again, we're going to review vertical asymptotes and horizontal asymptotes. Vertical asymptotes, you set the bottom equal to 0. Okay, so vertical asymptote at 0, horizontal, the degree of the top is a 0 because it doesn't even have an x. The degree of the bottom is a 1, so the bottom's bigger, so that's y equals 0. And then I type him into my calculator, and he looks like that. Vertical asymptotes, if I take the bottom and set it equal to 0, that's going to be x plus 3, x minus 3. So that's going to solve to an x plus or minus 3. Horizontal asymptotes, the bottom degree is bigger, so it's going to be y equals 0 again. So I have a vertical and a horizontal at 0. And then I graph him on my calculator, and he does a little bit of this. And then on the last one, my vertical asymptote, if I set the bottom equal to 0, I'm going to get x equals 5. Horizontal asymptotes, the degrees are the same, so it's y equals a over b, so that'd be 2 over 1, which is 2. So I have a vertical at 5 and a horizontal at 2. So he does this. Okay, so if you're coming into pre-cal, this is sort of foundational stuff. When we get into this section in pre-cal, we're going to learn slant asymptotes. We're going to build onto this. We will very briefly go through this one more time, but it will be brief. So if this is something that you're iffy about, I would pause it. Make sure you're good with your calculator. Watch it again. Go back over the rules. Write them on a sticky note, something, but they need to kind of be ingrained in your head. And if you're going into calculus, this is absolutely a review. I'm not going to review slants. They don't happen that often, but you just need to make sure that you know